So I think we're going to get started.
Sure.
So hello, everyone. Welcome to the Quant University Spring School session. Today, I'm excited to host Jacopo Tagliabue from Coveo. Jacopo gave a wonderful guest talk at my Northeastern University class. And he's one of those folks who actually does machine learning, not just talk about it and teach machine learning. He actually practices and builds machine learning systems. And he has intricate knowledge of what does it take to build machine learning systems. And after we spoke last time, Jacopo, I kind of explored a bunch of things on weights and biases and like how do you track experiments and the challenges with documentation of various experiments. And we've been having this conversation for a while. So I thought it'll be a nice session to basically talk about some of the challenges with data ops, and especially as the world is going serverless. How do we think about building in all these infrastructures so that you can focus on not only building out your machine learning models, but also building it in a responsive way, making sure that you're kind of taking care of all the constructs which are required when you're building out machine learning systems. So that's going to be the focus of today's session. So let me just kind of do a brief introduction before I hand over the stage to Jacopo. Just a second. We're going to bring up my slides. Okay, so for people who are joining the Quant University guest lecture series for the first time, welcome. We are based out of Boston, as I was telling Jacopo. We are focused on the intersection of data science, machine learning, and quantitative finance. And we have had training programs in an in-person setting for a really long time. We started in 2013, but the last year or so, we've been primarily doing all the programs online, and we've been streaming it on YouTube and LinkedIn. And we have seen people from more than 13 different countries take advantage of many of the classes we offer. And we have had more than 40 speakers from various parts of the world who have come down and shared their immense expertise and experience in various areas. So we're very thankful to they all spending their time sharing their knowledge. And we're also very thankful to you to support these programs and come online every week and then listen to these lectures. So hopefully these educational sessions have been helpful. One of the things we are trying to do, as most of you know, I'm originally from India. And last week we made an announcement that we would like to do something meaningful to support the relief efforts which are happening because of COVID-19 in India. As most of you know, India is going through a second wave, and back home, it's extremely devastating to hear the stories, the stories which come out in the media, the stories you hear from friends and family, the panic, the lack of supplies. Many hospitals are not equipped to take care of all the patients, and patients having to strive to get proper care. It's extremely devastating to hear all these stories. And we here outside of India are fortunate to sometimes benefit from the facilities we have in here. And we're trying to do our best to support the families and the folks back home, but it's been extremely difficult to do it in a remote setting. But I think many of the logistics are being worked out, and a lot of organizations are making sure that the oxygen concentrators and the tanks and the supplies and the medication required are being sent out to India. So to support those efforts, we are doing a donation fundraiser next week on May the 21st. On Friday at 12 o'clock, it's going to be a 2-hour masterclass. It's a donation base. Even if you can spare $1, I would really appreciate it. Please spread the word. And also, if you can join the class, I would very much appreciate it. And you all have been joining our programs on a weekly basis, and it's one way of giving back. And all the proceeds will go towards relief efforts towards the COVID crisis in India. So please spread the word, and also any support is very much appreciated. And the website is quforindia.splashthat.com. And I'll be sharing the links on the chat window and also on various forums. So I would very much appreciate any support. Additional announcements: we are gearing up for the summer school. Last time we did our first summer school, and we are very excited to start the second summer school. And we have a whole lineup of different programs. We are going to be running a machine learning and AI bootcamp, which runs 12 weeks. So if you are planning to get out of the whole COVID crisis and then come out of the whole crisis we've been having, fully educated and ready to take on the world of AI and machine learning, this is a program for you. It's a 12-week program. We're going to do it in 2 parts, a refresher on Python for data science for 3 weeks, and then machine learning and AI for financial professionals, which is going to be a 9-week course. Every week, there are going to be lectures, master classes, and also hands-on case studies we'll be giving you. And the goal is to have an intensive effort over 12 weeks to help you master many of the contents we have been gaining through experience in the field. In addition to that, we are also having a whole series of risk and AI programs, and we are partnered with Premier to offer 3 different programs, one for stress and scenario testing, one for algorithmic auditing, another one for model risk management. So I hope you take advantage of these unique offerings we're offering in summer, and all the program information is available at qusummerschool2021.splashsthat.com. One final announcement before we transition over. As many of you know, we have been discussing AI regulation and AI risk management for a long time in these forums. And we've been invited to participate in a panel put together by NVIDIA and supported by the World Economic Forum and the World Alliance for International Financial Centers. The program is on May the 25th. It's going to happen immediately after we end our session on May 25th. So if you can, please block out a 2-hour window between 11 to 1 o'clock, 11 to 2 o'clock on May the 25th. We'll have very many speakers and discussions happening. NVIDIA and World Economic Forum and a bunch of others are kind of joining in, and we're going to be talking a lot about AI and machine learning. So another program to consider. And again, this one is complimentary, so you can just go to the website and register. Okay, so without further ado, I would like to introduce Jacopo Tagliabue. Jacopo has worn multiple hats. So he was one of the founders of a company which got bought out by Coveo, and now he's leading various AI efforts there. So he has been working with really cool tools, Metaflow, and also looking at the whole notion of how do you build in intelligent search mechanisms and algorithmic marketing mechanisms. And they also are hosting a challenge, which I believe Jacopo is going to be talking about in a bit. So I will be handing over the stage to Jacopo. Just to note, next week we have a session on risk in AI and algorithmic auditing on May the 20th. And the details will be on Q Speaker Series 36.splashsthat.com. So without further ado, Jacopo, welcome. And I will hand over the stage to you.
Thanks so much. Can you give me right to share my screen?
Yes, absolutely. So you should be able to do it now.
Awesome. I think you should see my slides.
Yes, we can see it.
Okay, awesome. So thanks so much, of course, for having me. Thanks so much for the invitation. Since I had so much fun last time at the Northeastern class, I thought why not to build on that work and expand it a bit more for the spring school. So I'm Jacopo. I think we already went through a bunch of intro stuff. So I'm gonna just skip through that part, also because you probably have Google, so you can Google me. So this is what we're gonna talk today. If you have to take away one message from the entire presentation, is a message of hope. What do I mean? It means that today the field is mature enough for people that I call reasonable scale, as in not Google, Facebook of this world, but companies that have anywhere from 5 to 10 or 20 data scientists to reach incredible results with very little effort in scaling, maintaining, and deploying all the tools that you need. So this is really a talk of hope, and is a talk of how very few people can achieve incredible things thanks to the growing ecosystem of tools and open source stuff that has been around us. Of course, if you know what to do. And part of this talk is to teach you, or at least to explain, give you like a sort of opinionated view of which tool you need to pick and combine together in this puzzle to make you very productive. The subtitle of this talk is like Serverless Data Ops, which contains in a nutshell one of our main points in our philosophy, which is never deploy any infrastructure that you're not kind of forced to. For several reasons we're going to go into, but mostly because infrastructure is really not your job as a machine learning person, and you should strive and focus all your effort and all your energy into do what makes your business or your company succeed. So very quickly on my part, because I think I've been already like well introduced. So I'm Jacopo. I was the founder of Tuzo. Tuzo had 3 founders. I'm the handsome one in the picture. Tuzo was a company doing NLP and information retrieval, mostly for e-commerce use cases in San Francisco. So how it started and how it's going. So Tuzo was acquired by Coveo almost 2 years ago right now to jumpstart Coveo commerce product. And after that, I'm now part of this big North American unicorn. For those of you who don't, you probably know Coveo, but for those of you who don't know Coveo, Coveo is a like fast-growing company based in Canada and the United States. We raised more than $300 million in the last 3 years, and the company has like more than 600 people right now and is growing fast. What we do, we build AI solution for people that need to solve problems in e-commerce, customer service, or workplace. Workplace is what it used to be called enterprise search, which is basically the portal you give to your employee to find all the stuff that you do. If you are interested in every use case, I strongly suggest you to go on Coveo.com, which is very rich in content, and take it from there. What I do at Coveo, I'm the data scientist of Coveo, and Coveo has been, and my team has been recently present in basically all the top tier venue for the field in AI and NLP. This is just a subset of the publication in our last 18 months. The presentation has links. So if you click on the several links, you'll find like direct links to papers and stuff that you may want to read. This is not a marketing slide, or this is a marketing slide, but it's not a marketing slide in the sense that this is very important for what we're going to discuss later on, which is how such a small team and with relatively few resources compared to the Amazon of this world and the Google of this world be so productive in building cutting edge technology, as kind of proven by top tier conferences. And one of the reasons is the serverless approach that we're going to go through, which is this idea that this serverless data ops kind of unlocks a lot of value and kind of free your hand and your mind to be very productive in what matters the most, which is in our case AI innovation. So hope that's good enough for an introduction, and now let's go to the actual talk. So if you want to do ML at a reasonable scale, I think you need to understand a bit how we arrive at this point in like May 2021. This is a brief history of like ML. It's false, as in it's not really an history of ML, but it kind of highlights some of the phases that went into this into the industry. When the field kind of started maturing and progressing. So if you remember, there's going to be it was like a first phase in which only Google and Amazon, which is taken here as prototypical example of big tech companies, but you can substitute that with Facebook and Walmart if you want, do fancy model, and they do very cool stuff, and everybody's in awe to what these people can do. And then there's a second phase in which thanks to also some of the work that this company has been doing, for example, open sourcing TensorFlow and PyTorch, now kind of we can also do fancy models. And even smaller company can try to achieve the same type of model, but there's a second phase where people don't really know what to do with them. People don't really know what to do with them because models typically sit in notebooks and nobody has any idea or how to take this idea, which works on a paper or on a notebook, so to speak, and put them in practice. Because it turns out, and we're going to discuss about that if you look at the picture, the ML part of ML is very small. Like the model part of the entire ML chain is basically negligible. It's super important, but there's a lot of intelligence. But to make an ML model work, you have to have all the surrounding system like in place. And then we have a third phase, which it's kind of depending on how mature is your company. It may be a phase you're in right now, which is, well, there's a lot of pre-trained models out there. I don't know, you may know BERT if you like NLP. And what we do, we basically take this model that Google, kindly released. We fine-tune them to our use cases, and we deploy them. because now we kind of have hopefully find out a way to go from notebooks to deploying model. And we're going to discuss some of the ways in which you can do that in the unfortunate case that you didn't really figure this out by yourself. So what happens now, as in right now, if you went through all these stages, is that you find out that after now we deploy models, everything else is broken. So even now that we can actually have an endpoint that serves our prediction to people, there's a lot of things that don't work. Things include anything from how you do online testing to how do you monitor, if your model is doing what it's supposed to do, how do you retrain at scale and with a reasonable, time windows, and so on and so forth. So what is emerging as a general trend, again, this is a very opinionated view, but I stand by it, is that models are a commodity and data pipelines are the competitive advantage. As in the model itself, it's kind of become something that it's plug and play. And unless you have very, very niche need or you're doing very peculiar stuff, most of the models you're going to use are still models that have been tried and tested, by the community. So what you just need to do is to adapt them to use cases, which is a hard thing to do, but you know what I mean. It's not a crucial IP component of your system. Why data pipelines, that is how you go from the raw data to the final prediction and to monitoring and to testing, that's where the real value is, because that's what it's hard to replicate. That's what makes your company valuable. The second trend, which is kind of like a corollary of the first one, is that outside of very few companies, the typical B2C, and I'm going to explain why this is important, 95% or maybe 99% of data and model needs can be met with off-the-shelf tools. That is, if you do ML at a reasonable scale, what I call the terabyte scale, which includes 99% of companies in, in the world, basically, the ecosystem is now mature enough. Then you can use all sorts of tools and PaaS services to kind of bootstrap your system to be effective at scale. Why did I mention the B2C companies? I mentioned B2C as an explicit term, which means company that sells directly to consumers, because of a very important incentive problem that I think people and practitioners, especially people that want to jump into this market, needs to understand. A B2C company like Amazon develops AI system for themselves. That is, when Amazon builds a recommender system and deploys it online, if the recommender system is 1% more accurate, the difference in revenue, which in case of Amazon is probably the GDP of a small country, is going to be pocketed by Amazon. This Amazon has a direct incentives to build better system on their own website. They own the entire website, they own the data, they own the front end, they pay their employees, and there's a strong incentives in investing in having models which are marginally more accurate. If you go to a B2B company, that's the case of Tuso, my old company, or Coveo, or Bloom, Richard Goglia, whatever, the incentive is not the same. We build AI systems for other companies to be successful. So our goal is to make this company as successful as possible, which means deploying systems that are robust across a variety of use cases and that have been proven and tested in different verticals. Which means that the marginal value of a 1% increment on a given KPI is very different from a data scientist working in a B2B company than a B2C one. Which also means that's why most of the modeling aspect of a B2B company can kind of be taken from the existing literature and require a bit less creativity than what Amazon does at its own scale. So with my two theses kind of laid out for you, I go out and say there is a really fantastic model to be in this field, and mostly it's because you don't have to do much. As you can see here, there's like a bunch of logos. They're not meant to be in any way publicity, but just example of things you can go on and find online right now. We're gonna see some of them in the demo later. That will simplify your life in basically all the major aspects of what it takes to deploy like a model in production, starting from raw data. I think monitoring is missing here, but we can discuss about that later. So on the endpoint side and model serving, I pick just AWS because it's our hosting service, and AWS has been progressing tremendously in this type of tools. Our data warehouse, Snowflake is an excellent tool. Data transformation and quality, these are two open source tools, dbt and Great Expectation. AutoML, there is how you pick this model. Again, in this idea that models are important, but they're kind of becoming implicitly commoditized, especially in the first iteration phase. Ludwig, from my friend Piero, is an excellent choice. On the visualization side, preset, and then we have Metaflow for DAGs and orchestration. We pick Prefect, but it can be Airflow, which is excellent as well. And there's all sorts of these tools that you can use to kind of simplify your life. What we're gonna see today, which is how you're gonna take this tool, which the choice can be daunting. Like when you go online and you start Googling, now the ecosystem is so thriving that it may be hard if you're a new buy or if you don't know all these tools, if you didn't try all these tools, which one to pick. And I hope today we kind of help you with that. I thought today at least we give you at least one version of a tool chain that kind of works well together. But before going into the actual tool, I want to spend a bit more time on, again, the takeaway message that I hope you take away from like the general way in which you should build MLOps at reasonable scale. The first one is data is king. I know everybody says that, but then very few people do it. So data is king means that the most important thing of your company is your data quality. I cannot stress this enough. Like a stupid algorithm on good data will always beat a clever algorithm on bad data any day of the week, okay? So the marginal gain for you is typically now you collect, how you transform, how you engineer your data strategy. Because data is a really good competitive advantage, way more than model. If you remember my, the previous slides, models right now are kind of a commodity. So there's way less value in developing model because everybody can copy them. While there's a lot of value in collecting data and be good at your data, because even if somebody comes along in your market, is a new startup, they won't have all your data. Like data cannot be replicated, right? In the same sense the model can. Which as a corollary means if you need to build an ML team from scratch, and please, if you do and you want some suggestion, do reach out with me. I'm very reachable on LinkedIn or email. You should invest in that engineering before and more than in data scientists. Like a good modern ML team in a reasonable scale will probably have more data engineering than data scientists. The second point is focus on core and buy everything else, which is why we had all these logos in the slide before, and we're gonna have more logos in slide later. That is, our job is, at least my job as an ML scientist, an AI scientist, is not to build infrastructure, is not to build monitoring tool, is not to build scaling, is not to build warehouses. My job is to turn raw data into something that's valuable for my business or the business of my clients, or to turn raw data into some innovation that down the line will unlock, further value and so on and so forth. Which means that I should just spend all my time or almost entire my time focusing on what I do best and buy everything else. Something that again, it's often said, but then it's very hard to practice, is that the scarce resource you should optimize for is almost never money. It's typically time, because that's the resource you're never gonna get back. And especially if you're in a startup, time, which goes hand in hand with growth, which is the most important thing for a startup, is what you should really aim for. So if you're trying to innovate faster, have good iterations and so on and so forth, you don't want to be dragged by maintaining infrastructure which is not adding any value to your company. You want to buy or commoditize or outsource everything that you can, as most as you can, and you want to spend all your time in what makes your company valuable. Finally, even more controversially, at a reasonable scale, there is the terabyte scale, distributed computing should be avoided at all costs if possible. For distributed computing, I mean things like, for example, Spark. Either you use it, I don't know, on Databricks, you use the EMR, whatever you use. Spark has been a tremendous tool for the big data revolution to happen, and is obviously a genius solution, and is obviously the tool to go in many, many cases. But in the contemporary world, like in 2021, at terabyte scale, using Spark will just mostly slow you down. Because Spark, let's face it, is kind of slow. It's very hard to maintain. It's very hard to develop, the type of knowledge to require to run Spark cluster at scale. So now we have to have people that just do that all the time, which again, principle number 2 is not our core. And it forces very unnatural pattern on the people that builds data. Like learning to work with Spark is a job in itself, which means if we hire data scientists, we now have to spend months training him on just the peculiarity of Spark instead of giving him a system that works out of the box, which is not probably a very good use of expensive data science time. In particular, which is what we're going to say today, is that if you have a smart data storage system, let's say Snowflake for the sake of the example, you have modern laptops and/or easy access to scalable computing. Spark is really unnecessary for the type of incident that you're going to make at a reasonable scale. So distributed computing is a necessity at giant tech, but it's probably just a problem at a smaller scale. And you can always introduce it later on. Like if you have Snowflake and at some point you realize you need Spark, you can always build that on top of Snowflake. But the truth of the matter is, if you're good at feature engineering and good at your SQL table, the vast majority of the distributed part of your pipeline is going to be done in a SQL query in Snowflake. And everything else that goes into your laptop to train your model, it's just going to be, let's say, I don't know, 10 million rows or something like that, which is something that a modern laptop or a small container can totally handle. So this is a high-level view for what I call the moderate data stack for reasonably sized company, and we're gonna see an example of that. So on the left side, outside of our system, there are like things that produce data, things that just sends data to our system, and then what happens is that you're gonna put this data into a table in Snowflake, which we call append-all table. The append-all table in Snowflake is just a table that contains a raw event as raw as possible. And the whole idea of this system is that you first store the event as raw as possible, and then you have some sort of like replicable, repeatable, auditable system that turns this data into actionable insight. This system kind of decouples ingestion and processing, and which is very good because it may turns out that you find out that there's a mistake in your processing 1 month after you started ingesting data. But now, since you collected the raw data and raw data are there forever, you can just delete all the processing part that is downstream, and you go back to raw data, and you can kind of re-execute your pipeline to produce new data. So if you want to sleep well at night, I strongly suggest the first thing to do is to decouple ingestion and storage from actual analysis to do that. On the right side, and once data is on our Snowflake, we're gonna use an orchestrator, in this case Prefect, but Airflow could work as well. And we're gonna use a transformation tool, in this case dbt, to build tables out of this raw data. Tables are gonna go into different systems. If you want to do data visualization, you can feed this table to a BI tool, for example, Preset. If you need this data to do ML features, you may want to go to an intermediate step, which is data validation. Let's make sure that the data that we extract are kind of within reasonable boundaries. And then you're gonna build your entire model pipeline. But now your pipeline is kind of gonna be self-contained because a lot of data cleaning and standardization has happened before. So now you kind of totally decouple your ML code from your cleaning code, which is also great, especially in a B2B setting when you have hundreds of clients and you don't want everybody to kind of, like all the code to be kind of like, entangled together. When you're done with your pipeline, you just store the artifacts, whatever you want. And then, for example, you can push them to SageMaker, and now you have an endpoint. And basically now everybody can use the prediction that you did. So of course, all of this is super well and nice, and it looks nice on a slide, but how does this work in practice? And we're gonna see like a workout example on a real data set to show you, to give you a bit of a flavor of how that looks like. If you have questions, I don't see the chat because I'm full screen. So just raise your hand, or talk, or do something, or I don't know, maybe like try to capture my attention, or otherwise we're gonna answer to the questions at the end. I'm just saying.
Yeah, I'm watching it, Jacopo.
Awesome. Thanks so much.
We'll take all the questions at the end.
Okay, yeah. Awesome. Thanks so much. So let's start with a worked out example. We will need to skip through a lot of details because I want to devote some part to the documentation side at the end. But I'm happy to take it offline with more details. So this is a data set that you can download. It's called the free code camp Gitter chat, and it's basically a Slack-like data set that reports all the messages from the people participating in this code camp in 2017, I think, something like that. So when you actually look at the data, you're gonna find something like that, and all the people agreed for this data to become public, just so everybody knows. So when you look into the data, you can find something like this one. Like there's a person, just a first name as last name, that is kind of like, sending a message. And this message, as you can see here, may contain some mentions. So this is penguin of the sky. Actually, when you actually resolve the mention, it actually goes back to another user. And of course, the information about this user contains the avatar, which is the URL they use to display the picture, his name, and and some other metadata. What the data is composed of mostly is what you see in the top right left. That is all the data that you're going to ingest on this, simulating a system like the one we see before, are basically JSON file, each of one describing each of the the Gitter messages in this chat. So what you're going to receive is like 5 million approximately of these messages, and each message will be done in a way that I'm going to show you right now. So I think you still see my screen. You still see my screen, right? Yeah, all good. Yeah. So this is a message that you receive from this data set, right? So I'm not going to go through it. It's very intuitive. If you think of like what happens in a chat, so you're going to have some information about who's sending these messages. This is the famous avatar that I was mentioning before. You're going to have a message itself, which is this one, okay? And which is very handy. You're going to have a filter, which is called a field, which is called mentions. As you can see here, the mention field, okay, is basically reporting if in the text messages that has been sent, there's another user, right? So this is the user, and you can find it here. Okay, so this is, imagine 5 million of these events. And we want to develop something out of this. Let's say we want to develop a recommender system that, given a user and the message that he posted, we want to suggest other user to follow or other user to look up to. Okay, it's a very simple, like, ML tool. And this is the raw data that we have. So the first thing we're gonna do is we need to transform this raw data. As we see, this is the data that we ingested in something that we can actually use. You should see here my dbt cloud interface. So dbt is a tool that allows us to write SQL query that will turn the raw data that we saw here, so this long kind of unstructured JSON, into tables that everybody else can use. And the example that I want you to do is the user table. Okay, so imagine again you're working in this Slack-like data set, and there are two types of user information giving a message like this. There's the user that sent the message, is the from user here, okay, very easy, but also optional. There may be a user that is mentioned here, right? So this is the user that somebody mentioned in the chat. So the total amount of users in a chat is therefore the union of these two sets: people that send messages and people that are mentioned in messages. These two sets are different because somebody can be mentioned but never send any message, or vice versa. Somebody can send a message but never be mentioned by anybody else. Which means that if I want to develop a simple table, let's call it all users, I need to kind of go back to all this raw JSON and find first the user that I mentioned, and then the user that are sending messages, and then kind of combine them together. If you look at my screen, and again, I'm sorry, we need to kind of script to this, but what happens is that we're gonna write this small SQL function that are kind of gonna build one on top of the other. What do I mean by this? So let's take the query. This query is called all users, and it's a query that I think we can run it here. And it's a query that, when produced, is gonna give you a clean list of structured data, a table with all the users in your dataset. Okay. Yes, you see here, nice. So user ID, display name. This is like a clean data table that if you want to know who are the users in the dataset, that's the table you go to. But this table internally is made by two other tables. One that is referenced here, mention user, and one that is referenced here, sending user. If you follow what I said before, this is kind of self-explanatory. In fact, if you go into the mention user, okay, this is the SQL query that generates this data. Okay, we can run it as well. Okay, so what happens here is that we have a SQL query, like a very tiny piece of query that is going to build one specific information, which is the user that I mentioned. Then we have the user here. This query instead is going to tell you which user have been sending messages, and we're going to run this as well. Okay, you see here. And then from these two, like Lego bricks, we're going to compose these two Lego bricks, and we're going to produce the all user table, which is a table that kind of combines these two things, they duplicate them, and so on and so forth. Why is this useful? This is useful because if you think of somebody that just needs to, I don't know, display the users in some BI tool, or needs to work with user to build features, now we're not requiring them to know what is the raw data like. Like somebody can work with users without ever seeing this structure. Somebody can work with user just going to a database and tap into a table that is called all user. It's going to be select from all users. And this allows the separation of concern. So there are going to be people, data engineers that know the raw data very well, that are going to be responsible for the transformation. And there are going to be BI people or ML people that are going to build on top of that. This allows to have one clear standardized view of all the data for everybody. That is, all the parts of the company work with the same pipeline. But at the same time, it allows for teams to build on top of the work of each other. Now, instead of having this gigantic, horrible, transformation code that nobody can understand, this is SQL code that everybody can read and write. And this SQL code, as you see here, is very small and can be tested in specific points. We can show testing here, but trust me on this. So now we have all these small tables. They can be combined together to produce, what tables we want to do that. What can we do with this table? Well, let's take our database, like our dashboard. And so now I'm a BI person, right? So now I just want to, let me move my stack here. So now I just want to create a chart because I want to visualize something. And now I'm just going to take this table, which is like the final table that we produce. And we're just going to be a time series chart, and I'm going to create a new chart. Preset is the hosted version of Superset. So you can have this tool run in your infrastructure if you want. It's an open source tool. So if you look at this, we're going to just do range type no filter because this is older than last week. And we're going to do, I don't know, let's say we're going to do month. Okay. So in 3 clicks, you're going to see now that we can actually display the amount of messages that goes on into our chat. And then we can publish this chart to our dashboard for other users to consume. You can see here, like 3 clicks. And this is possible because this system is not looking at this, this messy table with all the data, but because this system is fed by tables that has been carefully prepared in dbt, which now means if somebody's just interested to, temporal pattern, he can just go in the right table that has been prepared for him and can display all the data and all the features that he wants. And this is very powerful. The last thing that I want to show, and then we go back to the slides, is, well, how do you orchestrate all of this? In our case, we're going to be using Prefect Cloud. So this is the flow that you see here. And what happens here is that all of this step includes simple Python code that calls, in this case, dbt Cloud. It calls Great Expectation and other tools, and they combine them together into this flow that you can run basically programmatically. And it's very secure because Prefect Cloud as well as DB Cloud do not exchange any real data. So they're hosted services, but they just exchange metadata that are like kind of necessary to kind of keep track of all of that. So you can take advantage of all these tools that are hosted for you, or without compromising on any security. So going back to my presentation, as I want to touch on the last part as well. So this will let you. So this is the DAG. So this is the exemplification of the relationship between all the tables that dbt will build, right? We just saw one, which is how you go from mention user and sending user to all users. But as you see here, there's a lot of other dependency you can go, and you can visualize this. So you can always trace back your data to where this data comes from. And of course, the second part, which we're not going to go through it, is, well, now that all the data is in place, how do you train a model? Our answer is typically with Metaflow, which is again a DAG. It's again something that lets you specify dependency between tasks, and there are many ways in which you can do that. Our favorite setup is something like the one you see here, which is a mix of local step and cloud step when you need GPUs. And the cool thing about Metaflow is that you don't really have to deploy anything, and Metaflow will take care of everything. If you're curious to have a working example of how to do a full end-to-end Metaflow deployment in a pedagogical but realistic way, we open source a repo and a blog post with that, so you're super encouraged to check it out. So when you put all of this together, you have a system that has, the Gitter datasets goes into Snowflake, and that's the raw data. And then you have Prefect organizing and orchestrating all these too. You have Preset for visualization, and you have Amazon SageMaker, which we haven't shown, but it's kind of a tried and tested technology to serve the prediction once your model is actually ready. What is the cool thing here is that you really do not need any server. I mean, you need one Prefect agent, but that's the only thing you need to make all of this work at a terabyte scale. Snowflake is entirely hosted for you, and it gives you the nice fast feeling that you're looking for. That is, you execute a SQL query, and Snowflake is just scaling that out in a distributed system without kind of you noticing. Prefect Cloud, as we see, can host and run and visualize and debug your runs. dbt Cloud can be used for as also a collaborative IDE for SQL transformation. Preset is an hosted visualization service. Metaflow will completely scale for you your AWS resources when you run it, so you don't really need to do anything, as also GPU provisioning and also on has been taken care by Metaflow. And of course, SageMaker is a completely hosted service. So you can basically build this entire pipeline with a tiny server. That is the only thing you need as a Prefect agent to basically run, the code. And everything else here do not require any DevOps resources. There's no people involved in spinning up any of this infrastructure. And this is dirty cheap. Like dbt costs, I don't know, like $40 per person, like a month, something like that. Preset is like 25. I mean, don't take my word for it, but kind of like in the ballpark. So we can kind of, pay all these cloud services that scales for us, and they maintain this thing for us, so that we can focus on what really matters, which in our case is what goes on into the Metaflow flow, like, the modeling and the understanding part of it, which is awesome. Because right now, it's true, we need to pay the services, but we kind of have free minds and free hands and free time to do what we care about the most, which is certainly not designing charts. Like, our job is not designing charts. My job is designing AI system that, that scales. So I think it's pretty nice. And if you want to know more of the details on how we combine all of this, because they include, for example, writing a small class for dbt Cloud and so on, please reach out to me. We're super happy to share code and best practices on this. So to conclude my talk, because I want to get some space for discussion, we're gonna go to the tedious part of documentation that everybody hates to do, but it's super important, especially in an ML world. Why is important? Because ML systems are way less predictable. I mean, software systems in general are not predictable, but ML systems are even less predictable than that. And so it's super important to have some kind of way to documenting what the systems are doing, known shortcomings, and what to expect when we deploy them in the real world. You may be familiar with model cards, which has been introduced by Google Research a couple of years ago. There's some nice paper and some nice example like online, and they're thought to be this reference for all for a model. They usually build a model, and then you have a page like the object detection page that you see there, which describe what the model is doing, give you some quantitative performancing, give you some qualitative idea of why the model works, why the model should not work, and so on and so forth. What is the catch? So is that model cards for Google are super nice, but they've been built, with designers and and fancy stuff and so on. What we really want is that we want to build model cards that are kind of automatically built when we build our code. Like, we don't want to do any extra effort to build a model card like the one that I show on the right. We kind of want to be that built in for free in our pipeline. So while Google cards are mostly satisfying a B2C use case, that is, you have a giant model like object detection that is available to basically everybody. In our company, it's slightly different, as our model requires way more domain knowledge and goes into a model again that somebody else is going to use. Since, as we said, ML is not really ML, but ML is always ML pipeline, what we wanted to do is to take this idea of model card and apply it to the entire DAG, like to the entire transformation that our model goes through in Metaflow, okay? So the actual form of our library is basically a script that runs on top of Metaflow classes and take as input a Metaflow class and generates automatically like a model card. So why can we use Confidence or, again, any other internal wiki stuff to document like, our flows? Well, there's a bunch of reasons. So the first one is that, Confidence, like updating Confidence is a quintessential manual endeavor. And again, we don't really want that. which also comes with the second problem, which is conference pages are static. So if you don't change them, conference pages become stale very quickly. But our model, especially in the beginning when you're trying to iterate, our model changed very fast. So, I mean, we've all been there. I mean, I'm guilty as well. You know, you change a model, but you forget to change, you know, the conference page. And so now people refer to a conference page that is not updated anymore. So what we want is that while I work on a model, all the changes that I make on the model are kind of automatically reflected in my documentation. And finally, which is more of a philosophical point, but since this talk is full of philosophical points, we're going to add one more. Conference pages are often not written in the same spirit as what we feel DAG cards are important. In particular, we feel there's a lot of value in forcing, so to speak, the people that build the model to sit down and think very hard on how to explain what the model does and, you know, the model shortcomings and some qualitative evaluation for people that are not technical. We just do not want people to focus on a, you know, completely abstract, you know, Grafana metric telling you, I don't know, precision at K for an information retrieval system. We want people that build this to think about how different segments of the user are impacted by this, how specific edge cases that may be important for our business are impacted by this. And we think there's a lot of value in having the people that develop the model to develop also this kind of domain knowledge, talking with other people in the company and making sure the model reflects that. So how is, you know, like a card like built? I think I can show one. So this is like a standard HTML like page that you can use. And so the card is kind of like two sessions. One session is the type session, which is kind of tells you, you know, what this card is about. This is a regression model. Again, all this code to generate this is open source, so you can find it online, and tells you basically, you know, what this model is about. Tells you, you know, this is the structure of the DAG, which is very simple. It's, you know, train model, join runs, test, end. It tells you which parameters the DAG accept, and it gives you into the details. So for each of the steps here, you're going to have a description of what happens and what comes next. Then there's a second part, which is the token part, the runs part, which does not refer to the general structure of the DAG, but it refers to individual run. That is, what happens the latest, you know, the last two times that we run this. In this case, you have for each of this run, you can see here, we have both like a description of the model. You have a reference to where this model is. So you can always retrieve this artifact. So you can always know exactly where the model that generate this mean square error is. And then you can have, like, you know, in this case, like a nice plot. I mean, again, this is like fake data, but it's a nice model that tells you, for example, in the last two runs, you know, what happens to the, in this case, the chart is between loss and epoch. And finally, you have the behavioral test. Behavioral test, again, we could spend a PhD on this, but behavioral test had this idea. There's a nice paper called, I think, Behavioral Checklist for NLP you should check out. But, you know, paper aside, is the general idea that there are cases that we want to test specifically outside of the general precision. For example, we want to test, in this case, we want to test what happens when the value of our, you know, dependent variable, so the independent variable is very low. And so we're going to simulate, you know, like a variable of like 0.57. And we say that we expect that when the model is very low, that our prediction is going to be very low. And it's red because in this case, our prediction is above 2, which is, again, it's kind of made up value, but you get the feeling. And then you can define instead of an expectation for something that is, you know, high X, and then you can kind of, you know, like, you know, see this as well, and so on and so forth. So this is to be able to do this, the person that kind of deploys this model, the person who is working on the model, needs to understand well enough the domain, maybe talking to PM, talking to clients sometime, to understand what are the edge cases that you need to include to have this monitoring. And so going back to the presentation, so when you actually go online and look at the code, you know, this is built by a very simple hack. So there's a card template, which is basically just a like HTML template, you know, just, you know, with just Jinja placeholder. If you know Flask, you know, Jinja templating engine. There's a card builder script that they use the Metaflow API, in our case, the tracking API, for us is weight and biases, to get all the information about the runs, the one that I display, and kind of substitute the placeholder in the Jinja template to produce the final HTML card that you saw. And then once you have an HTML card, you can do whatever you want. You can publish it internally, you know, as I don't know, as an H-frame, as an iframe in a Confluence page. You can have a serving server internally when people can go and look at that. You can just archive it as an S3 bucket, whatever you want to do. Again, if you want to know more, there's an open source repo with a detailed blog about this that kind of walk through to all the steps that we took to go from a Metaflow flow that we like, that is, a series of steps that trains a model, to the final example of how you build a card. So what's next? Well, a lot of things. I just want to put out there 3 topics for maybe discussions or food for thoughts. The first one is, what's going to happen to AI? So much has been said. The link there is to a nice blog by Andreessen and Horowitz. Much has been said about the scalability of AI company, which differs from typical SaaS and software engineering for all sorts of reasons. I think it's fair to say that nobody still has figured out the conundrum or the puzzle. But what is certain, and I hope I gave you a glimpse of that, is that small teams today can achieve great things in this thriving ecosystem by leveraging all these cloud PaaS services that you can just kind of tap into to free your hands to do great stuff. And so how does the ML team of the future look like? Again, for companies at reasonable scale, what is the right combination of data engineering skill, software engineering skill, data scientist skill, modeling skill? What is the best way in which you're going to build like a functioning ML team? On the MLOps front, I think we're seeing exceptional progress in the, in what I call the phases of ML history. So I think model deployment is now a solved problem, as you can literally buy, there are tons of startups that just do that, or AWS that just do that. Model monitoring is still an open problem, but there's a lot of solution out there that are trying to tackle this. So I would say is getting solved somehow. The new kid in town seems to be feature store. So I would say the feature store are getting started, and we're going to see maybe like a year from now, how important they are for the entire ecosystem as opposed to very specific company. But all this being said, what is the next big piece of MLOps that needs abstraction and automation? Like, what do you think is still missing to give to people that are practitioners in this field the same type of feeling that I got while I discovered Snowflake? I discovered Snowflake, I'm like, oh my God, this is awesome. I'm never going to go back to Athena or Spark or whatever. I mean, I love those tools, but this is a different thing. What is the next big thing that's going to happen in MLOps for, to make our life easy? And finally, a small part on documentation, because I think it's a cool and important part of the product in general. And I think somehow is underrated. Taking our dark cards, how can we make them easy to configure and extend? In particular, my team is going to be working with the Metaflow team on a prototype soon to kind of extend what we built. So if you want to join us or be kept in the loop of what we're going to do, of course, everything's going to be open source at the end. Please ping us. We'll be super happy to get your feedback or work with you on the topic. And now I'm happy to answer any question you may have. And again, please feel free. No question is too dumb. I ask anything, as I know I have to skip through a lot of details. So probably I'm the one to blame if some parts are not clear, but I'm super happy to clarify anything you may want to do.
Yeah, thank you, Jacopo. And we'll go to questions in a second.
Sure.
And I just wanted to kind of build upon what you said. And I think many people have seen this before in the Quant University series. And one of the use cases we are looking at is, the documentation piece you mentioned is to make it more formal. And I think you and I have discussed this multiple times on, what does it make to basically not only have a workflow which has multiple pieces, but also having this notion of understanding what workflows you have, and how do you kind of make sure that you're doing it in a way which is auditable, which is connected, and which you can understand the benefits of each piece and monitor all the pieces, right? So I think you were kind of talking about the model card, and we've built infrastructure around it, as you know, and many things we kind of build out is automatically generated. So it kind of builds upon what you've been saying. So it looks at various pieces of the puzzle on what metrics you're generating. And I think there is also the monitoring board in the context of, well, what can you potentially monitor when the machine learning model has been deployed in production, so you can understand the various aspects. So we're building infrastructure around it, and we're also excited on this new audit scoreboard, wherein we can periodically audit how good our machine learning pipelines are, and then rank them, and also look at the scores on what elements of it are breaking down frequently, and how do you make sure that you monitor those pieces, and also put in the requisite guardrails so that you can continue making enhancements to your process and make sure that you have a smooth working pipeline. So we're all in this together. We're trying to make the the machine learning pipelines and the machine learning workflows as seamless and intelligent as possible. So just wanted to reiterate that point as we discussed. Yeah, a couple of questions have come out, and I just wanted to bring that out. So one is very specific to Spark and DBT. So what's your take between Spark and DBT in data engineering?
These are very different tools. So, Spark offers like actually computation, as in, you execute a computation using Spark. DBT is a tool that is going to tell, in our case, Snowflake, which query to execute, and it's kind of orchestrate all this nice ballet with the dependencies. Like, remember the Lego brick analogy, right? You build atomic queries, and then you build on top of these queries to build more complex stuff and more feature. So these two are not really compatible. And my experience is that coming from a company that I built, which is Tuzo, on Spark and Airflow and Spark SQL and custom code to do all this, all this separation between ingestion and processing that I care about, it was a lot of work. We did make it work, but it was a lot of work where it required, honestly, like a lot of errors, mistake, and kind of like very experienced people. If you have to build a company now, or if you have the money to, if you have a company that you have the money to do some, the budget to do some restructuring, there's no need for that. That's why what I said, when I discovered Snowflake and DBT, I kind of throw away all my Spark and Athena. Like, I can't throw away all the other tools. I don't really use them anymore because there's really no need at the terabyte scale to do that. Like there's a lot of things to be said again about the role of Spark in getting the world to the point that is now. But if you are in a company that is not one of the 100 companies that we all know about, Facebook, Google, blah blah blah, it's gonna be like, you find out that the time that Snowflake is gonna save you is well worth the cost of having like a PaaS solution to do that. So that's my understanding. And DBT is cool because it's SQL, right? So again, if you're thinking strategically, you can now offload the data transformation to people that know SQL, which is significantly more and less expensive than people that know Spark. So it makes sense from a company perspective to migrate to these tools right away, unless you have petabytes of data every day. That's a different scale, and I have honestly no personal experience with that, so I won't comment on that.
Cool. So I got a couple more questions, and we'll go through them quickly. One is, I think there was a slide wherein there was this, I think it's a very specific third point on a slide about sparse SQL PSC. I mean, Yin, if you can elaborate a little more, I think I can ask Jacopo to chime in, but we'll go to the next question. So what are the cost considerations of using DBT?
Oh yeah, so okay. On the Spark SQL, I don't know if it's if you want to know more about Spark, please Yin elaborate on that so we can discuss. It's a topic that I know very well because I work in both ecosystems, so I kind of know very well. What is the cost in the DBT? DBT cost, I think it costs $50. If you want to do DBT Cloud, which is what I shown to you, which has this nice collaborative ID, you can schedule flow for you, so you don't have to do anything. It's just hosted. I think it's $50 per person per month, I think, but you can Google so it's very cheap. If you don't want, for whatever reason, to do that, DBT, all the functionality of DBT are open source, so you can install DBT in whatever Docker container you want, and you can maintain it however you want, and you can use it with Prefect or Airflow, whatever you want. So the cost is zero, and on top of what you're already deploying, but the cost is zero. My argument again, and I think goes in my philosophy, is never maintain anything that somebody else can maintain for you. So while I understand that maintaining a Docker container running DBT is still a negligible cost, I mean, for $50 a month, I can totally have the most of it, and I don't even have to think about this. But I do understand that people have different sensibilities on how to draw the line of what's your job and what's somebody else's job. But on my side is less infrastructure always wins against more infrastructure, always, all the time, especially if it's not runtime. I'm not saying that it's not bad if DBT job doesn't run. It's bad, but it's not as bad as an endpoint doesn't run. There's a huge difference between these two requirements. So I think you can live with a bit more uncertainty on the back end and just pay off people to do that.
Cool. Okay, so we are a couple of minutes beyond our scheduled 1 o'clock closing time. Thank you for all of you who joined and all the viewers on LinkedIn and YouTube. Jacopo, it's always a pleasure talking to you, and you always have a wealth of experience to share. And thank you for sharing the slides, and I've made those available to everybody who has participated. And looks like a very exciting architecture. I'm looking forward to see all the cool things. And also, please do share the lessons learned from the contest you're hosting.
Oh yeah, sorry, I didn't put a slide in there. So maybe can I share the link in the Zoom?
Yeah, yeah, please.
Please. One sec. Let me give you literally 1 sec. So if you guys can be so kind. Okay, so I'm gonna share this in the. I think it's gonna be everyone, panelists and attendees. Okay, so this is a link. This is the data challenge at SIGAR. SIGAR is the top information retrieval conferences. Coveo this year is hosting data challenge. If you want to test your skills on a new incredible data set that we just released, it's like 30 million event, 5 million sessions of real shopping data. If you want, please join us. I think it's going to be super fun. And of course, if you do well, you're also going to get a publication at SIGAR, because we're going to invite the best submission to come at the workshop and present the work they've been doing. If you don't want to do the data challenge, but you're still interested in using the data set for pedagogical and research purposes, please go ahead and do it. We share this, probably the biggest and richest data set in the e-commerce, research community ever, for people to use it. Like, we share it so that you can use it. I also see that Mark Leprince, I think, sent like a bunch of questions. Please reach out to me on LinkedIn. I'm very easy to reach out. You can find me very easily, and I'd be happy to continue the discussion with everybody that we can kind of talk today. Okay.
Thank you so much, Jacopo. And rest assured, we will have this data set in one of the assignments in the class I'm teaching in fall.
Of course, of course. Awesome.
Okay, so it's always a pleasure, and we'll see you
mine.
again next week for an algorithmic auditing session. It's again next Tuesday, so please stay in touch. Actually, next week it's going to be on the 20th. So please mark your calendars. The next session is on the 20th. Due to speaker conflicts, we are going to move the session to May the 20th, and all the details are on the Spring School website. So hope to join you all soon, and stay safe and have a wonderful spring. Take care. Bye-bye.
Ciao.